wrong with his mic.
I saw that it was muted.
Well, sometimes when I log on, it says your mic isn't working, and then you have to restart your Chromebook.
Oh, all right. Well, he'll probably come back then. There he is. Can we hear you now, Luke?
Can you?
Yeah.
Yes.
Is it working? All right, good.
Did you guys tell the girls they weren't allowed to come today?
No.
Yeah.
Okay. Last night you guys did homework on measuring angles and arcs.
Oh wait, what page was that on? Wasn't that 700?
We're on 656. 656.
Oh yeah, we went back a lot.
There's Grace. Hi, Grace. Thanks for coming. So the 5 of you bullied Lily and told her she couldn't come.
Yep.
Yep, pretty much.
Exactly.
No, Mr. Tosick just got done, so.
Okay, that's fine.
Yeah.
Okay, 656. I didn't think this homework was too bad. Okay, 1 to 9. Find the value of x. 1, Colby, and then 2, Brian.
For 1, I got 170 degrees.
Yeah, good.
I got 150.
Good. Okay. Questions on 1 and 2? Okay. Then we're going to do 3, 4, and 5. Luke, then Aristotle, then Grace.
Okay, so number 3 is a major arc, and 270
Good.
degrees.
4
Yes.
is a minor arc, and it's 59.
Mm-hmm. Good.
5 is a semicircle, and it's 180 degrees.
Awesome. Okay, good work. All right, number 6. This one, we didn't do an example yesterday, but there was an example in the book, so it's not hard, and I was hoping you'd be able to do it. So I'm back up to Colby then. Colby, number 6A. What was the measure of arc AB?
Okay, so I'm pretty sure that it's 15.
Well, so it's 9% for arc AB, correct?
Yes.
Okay, so take 360 and multiply it by 0.09. By 9. You just multiply by 9%. 360 multiplied by 9%. You should get 32.4. Okay?
Yes. Wait, I got 324. Wait, 360 times 0.9?
0.09, because it's 9%.
Oh, okay. Yep, that's better. 32.4.
Okay. Good. All right. Brian, 6B.
6B. Wait. 6B? Oh, yeah.
Yeah.
44.2.
Close. 43.2. Okay, 360 times 0.12. Okay. C, Luke, describe the type of arc that the category sports represents.
Major arc.
Yeah, good. Okay. Number 7, measure of arc STP. Aristotle.
You're muted.
Sorry, 147.
Yes, good. Number 8, Grace.
255 degrees.
Good. And 9. Hey, there's Lily. Lily, number 9.
Or not.
Guess she
Wait.
doesn't want to do it.
She left. Colby, number 9.
Oh, I can't see. It's really dark in my room. I got 6.5.
For PQR.
Wow. Wait a minute.
Because PQ is a 90 degree. So you kind of need to find QP.
Oh, wow. All right.
You have to
I'm
figure out
not
what
quite
QP is.
sure what I did there.
Okay, let me go to Brian, see what he did.
Which number?
9.
9. I got 123 degrees.
Yes, good. Yeah, you had to find QP, which is 33, and then add it to 90.
Yeah, I know. I got the other two. I'm pretty sure that I just completely did something else, or I just looked at something else and put it on 9.
Okay. So then we go to number 18. And we have to identify the arc again and find its measure. All right. 18, Luke.
It's a minor arc and 55.
Good. 19, Lily. Lily's back. 19, Lily. I feel like Lily's having computer connection problems.
I think so.
He's frozen for me.
Yeah, Lily, you're frozen on my screen. Sorry that you're having computer problems. 19, Grace.
Minor arc and 125 degrees.
Yep. 20, Aristotle.
20. Semicircle, 180 degrees.
21, Colby.
So that was a minor arc. And I got 65 degrees.
All right, so you're on 21, right? So you're going to go all the way from C to G to D. So you're going to the left. Start at C, go to the left to G, and then all the way over to D. So that's going to be bigger than a semicircle.
Oh, wow. Yeah.
From C to G is a semicircle. And then you
So
got
would that be a major arc?
That's the major arc. And then you have to add up everything
Okay, wait.
except for the
Then
55.
it's 305 degrees.
Yes, good. Yep, you could just subtract that 55 there. Good. All right, 22, Brian.
Major arc and 225 degrees.
It is a major arc, but I got 325. Let me just look at that. G to C to F. Yeah. 325. You're going to take 360 minus 35 because you're just missing that little piece there, the GF piece. And 23, Luke.
Semicircle, 180 degrees.
Yeah, that's it. Okay, there was one other thing in this section that we didn't talk about. We skipped over them. So turn back one page. We need to look at a formula. Okay. The formula for finding the arc length, which they call L, and it's not hard. It's x over 360 and then times 2 pi r, which is your circumference. And the x is however many degrees are in that arc length, okay? So look at 5A, and you guys will see just kind of how easy this is. So you guys, so we're all on the same page, 655. Okay. Page 655, we're looking at 5A. All right. And they want to know the length of arc length AB. So the length of that. So that's like, how big is that portion? Like you're going around the circumference. That arc length is that little piece of the circle there. All right. So for 5A, x over 360. So we use that 45 degrees. So 45 over 360 times 2 pi r, and r is 3. All right, so you guys can just use your calculator. 45 times 2 times 3 times pi, all divided by 360. Okay.
I don't think that's right. Should we be getting a small number?
Yes.
Oh,
What-
okay.
What did you get?
I got 2.4.
That's it. They said nearest 100, so we're going to put it at 2.36.
2.36, yes.
Okay. That's it. Okay. So let's look at 5B. They want to know the arc length of from A to B, and we see that 80 degrees there. So we're going to do 80 over 360 times 2 pi r. R is 7. You could do pi d. It'll give you the same thing, but right. 80 over 360 times 2 pi r. And you just do your 80 times 2 times 3 times pi divided by 360.
I think that.
And Grace, what did you get for that one?
Give me a second. 19.54.
Try it again.
No.
Okay. What did you get this time, Grace? Oh, did Grace cut out too? We're having bad internet today. Brian, what did you get?
0.7. Probably not.
Okay. You got your calculator? Okay. Do this. 80 times 2 times 7 times pi equals divided by 360.
$0.06.
Really? Luke, what are you getting?
9.77.
Yeah.
Wow.
I don't know what's going on with yours, Brian.
Nor do I.
All right, try it this way. All right, clear out your calculator. Okay. 80 divided by 360 equals
Yep.
times 14
Yep.
times pi.
Now I get
What-
9.77.
Okay, good. I don't know what was going on before.
Pretty sure that's what I did the first time. Huh.
Yeah, I don't know. Okay, well, that's how you do those problems. So I'll probably give you a few of those to do tonight. Just have to remember that. Okay, because I want us to read about in the next section, arcs and chords. Okay. Page 661. Okay, arcs and chords. A chord is a segment with endpoints on the circle. All right, you guys learned that yesterday. If the chord is not a diameter, then its endpoints divide the circle into a minor arc and a major arc. Okay, we have a theorem, of course, because it wouldn't be geometry if we didn't have theorems.
Of course.
Okay, so in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So again, it's like common sense. If the chords are congruent, then their minor arcs are congruent to each other. They use a proof to show this to us, and they're like, wow, that's true. Okay, so if you have two chords that are congruent, it means their arc lengths are congruent. If two arc lengths are congruent, this is the opposite. It would make the chords congruent. Okay, let's look at the example 1 at the bottom of page 661. They're showing an embroidery hoop, and they're saying that segment AB is congruent to segment CD. Okay, those are both chords. The measure of arc AB is 60 degrees. Find the measure of arc CD. Oh, they're the same chord length, so they're the same arc lengths, 60 degrees. All right, let's look at number 1. If the measure of arc AB is 78 degrees, find the measure of arc CD. Aristotle, what would that be?
78 degrees.
Good. Okay. So there we have that to think about. All right, let's see. What are they going to tell us next? So let's turn the page. We have two different circles, circle J and circle K. And we have arc length MN and arc length PQ. And we have to find arc length PQ. All right, so they tell us these are congruent arcs in congruent circles, so their corresponding chords are congruent. They're equal to each other. One equals 2x plus 1. The other equals 3x minus 7. They solved for x and substituted it back in, and they found that the chord equals 17. So we need to do that for number 2. We have a circle W, and we have two chords or two arc lengths that are congruent, and we have to find the chord. Okay, so you're setting them equal to each other, solving for x, and then telling me how long the chord is.
Which one is 5x minus 9 and which one is 2x plus 3? They're so close.
They are so close. I think 5x minus 9 is RS.
Yeah, because it's up.
Oh, God.
2x plus 3 is TV.
I think I got it.
Ryan,
Yeah.
did you get this number?
Okay.
What
So
number?
we're finding RS. Grace, what did you get? How long is chord RS?
RS is.
Wait, I got, yeah. Yeah. Yep. We are in ingredients. The Council of Math.
The Council of Math.
Okay. All right. You guys are solving for x and then substituting it back in. Okay. What did you get for x, Grace?
Give me a second. Because my computer cut out.
Oh, okay. Do you know where we are, though?
Yeah, I have x equals 4.
Okay, good. So substitute that back in to either of the arc lengths because they're the same.
11.
Yeah, good. All right, Grace figured out x is 4, and that makes the chord 11. Okay.
Oh, that feels like homework.
Next idea, bisecting arcs and chords. All right, take a look at this. If a line, segment, or array divides an arc into two congruent arcs, it bisects the arc. Okay, so we have some theorems about that. If theorem 9.3, that example says if diameter AB is perpendicular to chord XY, then XZ is congruent to ZY, and XB is congruent to arc XB is congruent to arc BY. And also, the perpendicular bisector of a chord is a diameter or radius of the circle. All right, so if it bisects it at it's a perpendicular bisector, then that means that it was a diameter or a radius. Okay, so they'll do an example. In circle S, the measure of arc PQR is 98. Find the measure of arc PQ. Well, radius SQ is perpendicular to the chord PR. So by the theorem, SQ bisects arc PQR. So arc PQ and the measure of arc QR are equal to each other. So we just have to divide by 2, and it's 49. Okay. Let's try number 3. I feel like these are so easy. It's kind of like ridiculous. Like, I feel like you're looking at it and you're going to want to do something that's harder. Number 3, in circle S, find the length of PR. Okay. Colby, are you still with me?
Yes, sorry.
Okay. Colby, what's PR?
PR is, wouldn't that be 12?
Yes. I can see you're like hesitating, like that is really too easy, but yeah, that's it. Yeah. It's being bisected by QS. So yeah, we double it. It's 12. That's it. Okay. They did another example for us on the next page, like with a drawing. And they have to, this time they have to use the Pythagorean theorem. And sometimes we're going to have to use the Pythagorean theorem also. Okay. They had a stained glass window with a diameter of GH 30 inches long. Chord KM is 22 inches long. And it forms at makes a right angle. Okay. So that makes it a perpendicular bisector. And, but we don't know how long some of the pieces are. We know that GH is 30. We know that JH is 15. We know all radii of a circle are congruent. So that makes JK, the radii that we drew, the radius that we drew, 15 also, because it's also a radius. So we know JK is 15. Okay. Because the diameter of GH is perpendicular to segment KM, segment GH bisects chord KM. So KL is 1/2 of 22 or 11 inches. So now we know KL, we know JK, and that means we can find JL. And they go through, and it's about, it's the square root of 104, which is about 10.20 inches long. All right, so it's like about 25 after. I'm going to give you some to work on. And I put some videos in your Google Classroom on this. So when you're working on it, if you want to hear more about chords and diameters in this theorem, I put some videos on there to help you. I did talk to Mahak yesterday because I wanted to know if they were doing a final. I just wanted to know like how much I should torture you with taking the final. And she said they are not taking a final exam. She said they don't have class. They have like the packets, you know, like she had packets, sort of like the packets we had that we were doing when we were in school. So they just have to do the packets. But they don't ever check the packets. So they just have the packets, and they're just doing pass fail. They don't get a grade. You guys do get a grade. You know, you guys are pass fail in your specials, but you're still getting a grade, a letter grade in your classes. They're just pass fail. So I'm assuming a lot of people aren't going to do their packets. But Aristotle, are you raising your hand to me? Yes.
Yeah. How do I know when they're asking for the arc length or the measure of the arc? Because when they're asking for, because when they're asking for arc length, they said the measure of like AB with like the arc above it. But then when they asked for the measure of it, they did the same exact thing.
I'm pretty sure, but let me look back. When they do the measure of the arc length, when they put the M before it, then it's, if the M is before it, then it's just the length of that piece on the circle. And if they
Okay.
just have the arc, then it's like that arc piece inside. So it just depends if the M is in front of it or not. Okay.
Okay. Yeah.
All right. So I'm going to give you on page 656. That's on the same page you did your homework last night. Numbers 10 to 13. Those are the ones where you're using the formula that we did today.
Okay.
Okay, and then in this new section with arcs and chords, let's do I'm going to say 660. My markers are drying up. They're like you're getting to the end of the year. 664. And one goes on to 665. I'm just going to give you numbers 1 through 6, and you might have to read the other examples. But we'll go over those ones tomorrow. So, okay. You're going to have to end up drawing the right triangles, and there are the videos in there to help you with that if you get stuck. So you can go to your Google Classroom. Okay? All right, guys. Have a good day.
All right, see you later.
Bye-bye.
Thank you.
You too.
You're welcome, Aristotle.
Goodbye.
Bye, Brian.